Hello everyone, in this project we are going to talk about generating requirements for AGI using the current generation of LLMs, current generation of AI. So AGI is quite an abstract and theoretical topic. It's not something like a physical object like a car or a toaster. So it's going to be very interesting in how AI tackles an abstract and theoretical topic and how it defines generation for them. Now, it's also going to be very meta and it's also going to be very interesting as we see how current generation of AI is going to develop defined requirements for the next generation of AI. So take a seat and yeah, we'll dive deep into the project. Okay, so let's talk about artificial general intelligence and why we picked that for our project topic. AGI right now is extremely abstract and extremely theoretical concept. We are not sure when it would be invented. It might take a couple of years, it might take a decade. We are not sure yet. But AGI, artificial general intelligence, has been theorized as something that would excel or match human intelligence across various fields, almost across all tasks. It would have flexible problem solving just like humans. It would be able to have uh, the power of transferring domain knowledge from one domain to another knowledge and apply and create new independent work in different domains. It would be able to apply skills from one area to another area and create unique work, unique original work, which would help solve problems. It can be probably going to be an excellent coder. It can probably cure cancer. That's what we hope so from a from an entity which is super intelligent. It's going to write excellent amount of code. It's going to improve upon itself. It's going to do a lot of research across a lot of various domains, and the timeline for artificial general intelligence is quite uncertain. And also, the reason we choose this topic for our project is it's incredibly meta in a way because we are asking current generation of large language models to theorize requirements for next generation of artificial general intelligence. So as you will see in the upcoming slides, it can get quite interesting and how different LLMs tackle this problem. There's a lot of observations and a lot of things to learn from this project. At least we believe so. And apart from that, the timeline for general intelligence is quite uncertain. As I mentioned, it can be decades or it can be never, or it can be like within 3 to 4 years. No one would know. And once we discover AGI, once we invent AGI, it would transform society and raise concerns in a variety of ways. There would be concerns about job displacement, control, ethics, and quite a lot of things. And that's it. Now, before we deep dive into the presentation and talk about various LLMs and the interpretation of AGI, I wanted to have a small note about the RAG and the in-course guide. So I was playing around with the anything LLM software, and one thing I noticed is that my laptop is not powerful to run local LLMs. Like even the 7 billion parameters and 10 million parameters models were like struggling on my laptop. So I searched around and what was the issue. And while I was searching around the issue, I understand that anything LLM creates RAG for the documents that you upload, but a normal LLM like maybe ChatGPT would not create an LLM and would not create a RAG for a document unless it's required to do so. Cloud also does RAG, but only for cloud projects of certain size that excels at certain size. So I researched a little bit more about RAG, the retriever, and chunking and everything, and vectorization and everything. And what I understand right now is that we can get away without using RAG for the in-course guide because the size of the in-course guide is not that large. It can fit inside the context window. So we can use that. We can directly upload the in-course guide into the chat, into the context window, and we would be fine. And it would be a better way to approach this problem instead of RAG, because RAG is a semantic search. It would try to fetch fragmented documents, right? But If the document is inside the context window itself, then the entire context of the document is understandable by the AI and not just a fragmented chunks of it. So yeah, in-course guide would be in the size of, so overall the size of the in-course guide is not that large that we have to worry about rag in this situation. And yeah, now to give you an overview of the project, we picked 4 of the best LLMs in the industry right now: Cloud Sonnet 4, Gemini Flash 2.5 Thinking, DeepSeek R1, and ChatGPT 4o. We ask all of these LLMs to create requirements for AGI with the in-course guide and without the in-course guide. So we started off, as we'll see in the next slides, that we started off by just giving a basic single line prompt firstly, and the prompt was just creating requirements for AGI. That was it. That was just a prompt. Everything was up to interpretation for everything else was up to interpretation by the LLMs. So yeah, let's discuss the requirements and do some basic analysis about all the requirements generated by the 4 LLMs that we mentioned in the previous slide. Now let's talk about the requirements generated for AGI by the DeepSeek first of all. So DeepSeek demonstrated the most business-oriented approach to AGI requirements generation. It immediately structured the problem using traditional business framework with like Roman numeral categorization, which believes it suggests a background heavily influenced by enterprise and regulatory environments. At least the training data was quite heavily based on enterprise and regulatory environments. The standout feature for DeepSeek was its commitment to quantification. Like, this was the only LLM in the first round, in the step 1, which quantified the requirements in any way. One of the quantified was like 99.99% adherence to ethical guidelines, which is very interesting because it's not that technical, it's not that quantifiable, it's still quite abstract, that requirement, but it was still some numerical quantification given by the DeepSeek LLM. Apart from that, DeepSeek's regulated sophistication was quite interesting. It was the only LLM which talked about the EU AI Act and IEEE ethically aligned design standards. This would probably mean that the training data heavily weighted on recent policy documents or an architecture specifically tuned for compliance-oriented thinking, which is very interesting. And the philosophical stance for DeepSeek is also quite explicit. It mentions that AGI must remain a tool for human flourishing and not an autonomous utility, not an autonomous entity with intrinsic goals. So yeah, this view sets it apart from the other LLMs that we'll discuss in the upcoming slides. And apart from that, this LLM also talked about Turing test, Turing plus test, and task agnostic benchmarks, which is very unique to DeepSeek. I know DeepSeek R1 has been out for like more than 6 months and it has not been updated. Probably it's still quite 6-month-old version of the LLM, but it still did quite pretty well given the prompt. The prompt was just very vague prompt about generating AGI requirements, and everything else was up to interpretation of DeepSeek. However, DeepSeek's weakness lies in technical architectural details, and this would be the weakness across all 4 LLMs except ChatGPT. We'll talk about ChatGPT dedicatedly because it was quite interesting. But yeah, however, in this situation, DeepSeek weakness lies in technical architectural details. It gives strong details on what AGI should be and what it would be, but it did not give much requirements. It did not give much technical requirements. And by the way, everything that we are talking about, there's a Google Doc that we are uploading. There's link to Google Documents at the last slide, and you can check out all these requirements yourself if you wish. Okay, so now let's talk about Gemini and the requirement analysis. for Gemini's AGI. So Gemini took the most academic and theoretical approach to AGI requirements. Rather than jumping directly into the technical specifications, Gemini began by establishing the conceptual foundation for AGI by asking the question, what's AGI, before determining the requirements. This reflects a more scholarly and research oriented perspective on requirement generation for AGI. The most distinctive aspect for Gemini's approach is its risk first mentality. It was the most risk averse of all the four LLMs. While other models treated safety as one category among many, Gemini positioned safety and alignment as the primary concern and then conjured all the requirements on the basis of it. Gemini was also unique in emphasizing embodied physical cognition. The idea that true AGI comes with physical interaction within the world. This position suggests influence from cognitive science research that argues that intelligence emerges from environmental interaction, not just abstract computation. No other model required physical sensors and actuators as a fundamental AGI components and fundamental requirements for AGI. Apart from that, the computational sustainability angle is also quite distinctive and it's quite unique to Gemini. Gemini explicitly questioned whether the current approach of simply scaling up models are sustainable, showing awareness of the environmental and resource cost of large-scale AI system. This systems thinking approach considers AGI development within the broader ecological and economic constraints. However, talking about the downside of Gemini was the weakest of all four models, both with the guide and without the guide. Gemini's narrative and academic approach result in the least actionable requirements. It had quite a lot of vague statements in its requirement generation. While it was philosophically sophisticated, no doubt, but the vague statements provide limited guidance for actual development teams. The requirement lacks specific metrics, testing methodologies, or implementation pathways. Gemini also showed the most resistance to technical precision. Even when discussing computational requirements, it remained at high level rather than providing concrete specification. This suggests either a training bias towards conceptual over technical content, or maybe it was a deliberate choice to remain solution agnostic. I would assume it's a deliberate choice to remain solution agnostic. Now let's talk about Claude. Claude demonstrated the most systematic and comprehensive approach to AGI requirements generation. It produced quite a comprehensive requirement doc with many categories and subcategories. This hierarchical organization with 8 major categories and extensive subcategories reflects an engineering-minded approach to requirement generation. Also, what sets Claude apart is the breadth of consideration. While other models focus primarily on cognitive capabilities or safety concerns, Claude was the only one to include detailed requirements for emotional intelligence, social understanding, and even empathy. So this holistic view of intelligence suggests training that values full spectrum of human cognitive abilities and not just logical reasoning or problem solving. Also, the technical depth of requirements is quite impressive for Claude compared to Gemini and DeepSeek. It had requirements for working memory, episodic memory, semantic memory, and retrieval mechanism, showing sophisticated understanding of cognitive science research. The level of architectural details through these requirements provide maybe concrete guidance for system designers while still being like solution agnostic, similar to what Gemini did. But Gemini did not had any extensive architectural or technical requirements or technical implementation in the requirements at all. Claude was also unique by generating metacognitive requirements. The idea that AGI should be idea that AGI should have self-monitoring and introspection. So there were like requirements about introspection, self-monitoring, which represents significantly beyond what current AI systems can do. This self-awareness capability could be crucial for AGI safety and alignment, and Claude was able to produce requirements for this, which was very unique and very thought-provoking in a way. And the vision through Claude's requirements suggest AGI as part of collaborative intelligence ecosystem rather than a standalone replacement for human intelligence. However, Claude was quite comprehensive, which is good, but at the same time, it was some of the details, some of the requirements were very vague, as you will see in the requirements doc that we have attached at the end, attached in the last slide. Some of the requirements are still vague, and some of the requirements are still not as technical as we would have wanted to be. And it suffered the same issue as all other all other LLMs in this first round. Without the in-course guide, the requirements were not measurable at all, and the requirements were not quantifiable at all. Most of the requirements were not quantifiable. However, from a system design perspective, Claude approach provides the most complete roadmap of all the four LLMs, but at the same time, it can be quite overwhelming by producing such an extensive requirement doc. Now let's talk about ChatGPT. ChatGPT come up with quite an interesting requirement doc. It generated one of the most innovative, I think, of all the four LLMs, one of the most innovative approach towards requirement generation and systems architecture. So ChatGPT took an innovative structured approach and it came up with a 5-layer architecture. It built AGI requirements from a hardware foundation all the way up to existential considerations. This unique system engineering perspective, I think, reflects a very sophisticated understanding of how complex systems are actually built. And it started with a physical layer, and it built abstraction layers on top of it. And it was quite interesting. You should see the requirement doc that we have attached for ChatGPT in the last slide. So the technical depth was quite remarkable. It came up with an hardware layer, which was like the layer 0, and then it built everything on top of it. In the hardware layer, it was talking about neuromorphic and hybrid ASIC requirements, energy efficient architecture, persistent self repairing storage. It sounded very science fictiony, and I'm not sure how much of it was true and how much of it was just made up. But it was certainly a very interesting read, certainly a very interesting requirement doc read. Uh, so this hardware consciousness suggests training which was heavily influenced by system engineering and computer systems content. I think and understand that software capabilities ultimately depend on physical substrate limitations. This was very unique understanding compared to the other three LLMs. So ChatGPT is innovative. ChatGPT was also very innovative in temporal abstraction, which basically means ability to have requirements which think about like long-term planning. So it was the only LLM to come up with requirements about long-term planning, which is something that other LLMs could not do, and it is something that none of the LLMs can do right now at all. Long-term planning would mean long-term memory, and that's why I think ChatGPT started by building requirements for long-term memory in a base layer. Also, the capability control concept was quite unique among all the models. ChatGPT explicitly requires AGI to constrain its own influence until confidence thresholds are met, which is essentially building humility into the requirements and architecture. This self imposed limitation approach to safety is more nuanced, I feel, compared to other LLMs. However, ChatGPT was very technical, extremely technical, I think the most technical of all four. But however, ChatGPT's technical focus comes at the cost of human factors. It was technical, but it did not have any requirements about emotional intelligence or a regulatory framework. It also had very limited guidance on how AGI would interact with social and organizational systems in our physical world. From an implementation standpoint, ChatGPT's approach was the clearest, as I said, clearest technical roadmap, but it requires significant expertise in computer systems architecture to fully appreciate and execute. Okay, so now let's summarize everything that we have learned from previous slides into one single comparative slide. So let's talk about the structural differences between the requirements. So DeepSeek had a very business framework which suggests training heavily influenced by corporate and regulatory documents. Gemini's essay and narrative format reflects academic paper structure. Claude had hierarchical categorization, which systematic engineering thinking, and it was the most holistic of all the three documents. And ChatGPT's 5-layer architecture is oriented towards computer science framework. And these aren't just stylistic differences in requirement generation, they also represent structural and fundamentally different ways to solve a problem. solve a complex problem and quite an undefined problem. Also, let's talk about the philosophical divergence. Perhaps the most striking uh, perhaps the most striking was DeepSeek view of AGI as a as a tool for human flourishing, and Gemini seeing understanding AGI as an existential risk requiring careful management. Claude treats AGI as an comprehensive intelligent systems requiring human-like capabilities across all the domains, and ChatGPT approaches AGI as a bottom-up engineering system which needs to be built from hardware constraints upward. These philosophical differences would lead to completely different AGI development strategies. Also, the training bias is quite evident in all the based on the requirement generated. The training bias is quite evident. DeepSeek was probably trained on quite a lot of sophisticated policy documents. Gemini was probably trained on quite a lot of academic literature. Claude was trained on comprehensive. Claude was quite comprehensive. It had training documents from all across the spectrum. And ChatGPT's technical depth indicates strong influence from computer systems and engineering content. Also, I was going into this project, I was expecting that all the four LLMs would create very similar requirements, but it was not the case at all. All the requirements generated by all the four LLMs was quite unique, and you cannot solely rely on one single LLM for generating the requirements. You'd learn new things. You'll understand new perspective on requirements. You'll understand new perspective on systems engineering by going through all the requirements generated by all the four LLMs, and then you combine and mix and match, and that's how you come up with a really great requirement specification doc by combining requirements across all the four LLMs.
Till now, we got to know how our requirements were generated without using the Incozy guide, and how the LLMs reacted to each of the prompts. So now we are going to look forward to generating requirements with using the Incozy guide. So continuing our requirements analysis, first I wanted to start with DeepSeek. So for DeepSeek, what I found out was DeepSeek showed very genuine understanding of Incozy. It didn't just follow the format but grasped the purpose and the methodology. It also cited Incozy rules such as C1, C6, and R34, which shows meta awareness and a greater perspective of learning towards Incozy. Then what I found out was its integration with many multiple different standards, which is it merged IEEE, NIST, IEC and also SIL3, which demonstrated real world standard interoperability, which is needed in an industry. Then I saw that uh, the verification methodology was updated or upgraded. How it did that was it added matrices and defined how to validate them. Methods such as fault tree analysis, adversarial benchmarks, third party audits were used. Such verification shows the importance of the requirements itself. It also showed a hardware safety evaluation. It integrated SIL3 safety with stop commands, and then it showed life cycle thinking, such as including failure modes, which I found was very interesting compared to other LLMs. For engineering precision, it shifted from compliance standards to technical targets, which made sure it balanced both the compliances as well as the design technicalities. Uh, Overall, the implication of AGI development, it likely trained a new standard document, and understanding of compliances was important, and it gave a realistic pathway for regulated AGI deployment. So that was about DeepSeek. For Gemini, it resisted the structural adaptation. Unlike other models, Gemini retained its original conceptual style. It suggested strong training bias towards academic limits in adopting structured engineering formats. Uh, so it did not change way too much. It came out with an abstract language persistence, which is that it continued using the broad phases despite Incosys push towards precision of these phrases. It indicated preference for conceptual framing over specification details. It was minimal. The matrices which Gemini made were very minimal. Only measurable criteria added 99% uptime. Uh, Also, to contrast to DeepSeek, which had multiple matrices, Gemini had detailed benchmarks. So instead of having many parameters, Gemini focused on having benchmarks as their USP. Uh, so this made it difficult in translating concepts into quantifiable requirements. So the next thing which I found very different about Gemini was it lacked standards of integration. As we spoke in the previous DeepSeek slide, DeepSeek used IEEE, ISO, or any similar references, whereas Gemini did not. Gemini stuck to only one, which is Incosi, and that too it was not was not ready to adapt it fully. Uh, there were no compliance pathways, nor there were defined verifications, and there was very limited exposure to actual standard documentation. Uh, so where do we think Gemini can fit as a good use case? It is a good use case when it is a matter of conception. In early research phases, in conceptions, Gemini is suited, and it is less suited for systems engineering phases that demand precision, measurability, and compliance training. So, Gemini, if you are going for ideation, is useful, but for systems engineering problems, it is less preferred. Going forward to Claude. Uh, for Claude has had balanced expansion. It grew from 8 broad categories, 18 specific requirements it gave us. It showed understanding of INCOSI compliance, making comprehensive thinking measurable, uh, and not abandoning it as we saw in Gemini, which was totally conceptual. It has depth preservation, which means it maintained holistic intelligence view, emotional processing, social understanding, and also cognition for like to a point. It gave measurable matrices, which is like example you can see from the links which are given below. You It gave parameters such as episodic memory accuracy or multi-step reasoning accuracy, which are parameters required for AGI. With numbers too, I forgot to mention that like it was very specific. It was somewhere between 90% to 95%, but it was very specific with the numbers. uh, it integrated security architecture, so it was including ethics, explanation, human oversight. uh, so it was very multi attributed systems level thinking, I would say. Then what I found interesting was, if you gave it an abstract topic, it usually quantified it, and as I said, in matrices, it was very specific in giving these matrices. And then the training insight, like it took exposure from references from both academic researchers as well as practical engineering frameworks. It bridged theory and implementation, the gap between theory and implementation. So that is what I found very interesting with Claude compared to others. Now coming towards the holy grail of the LLMs available, ChatGPT. ChatGPT, what I like about is its framework application in ChatGPT is very excellent. It had a very strong technical foundation. Using Incozy made it more rigorous and specific. It maintained its original systems engineering approach, but with very sharp precision, as mentioned in Incozy. So Incozy checked. Uh, Security standards integration. They added ISO and ISC compliance and showed a understanding of security. Like it was not just a feature, but it was full understanding of the security with the framework given. So that is what I found very interesting in ChatGPT. Uh, then quantification, yeah. So as mentioned in some other LLMs, ChatGPT showed good quantification uh, with the AGI requirements, such as for energy. Uh, it also had traceability logs, where timestamped logs of all actions, decisions, and interactions can be given, uh, which is very good. Uh, uh, Other thing which I found interesting was, yeah, coherent systems thinking requirements are interlinked to mutually reinforced systems. Like they are mutually reinforcing each other, and this kind of synergy is very important when we give some kind of requirement analysis or requirements. So these requirements were in sync with each other, and they had a good synergy. uh, it took exposure and references from technical documents as well as systems engineering concepts. uh, so it told us what systems must do and how to build them for reliability and its maintenance. So ChatGPT take. Going on to the comparison. So as we compare all these four LLMs, we saw various different things, such as structure. Structure is very different in all the four candidates here, which is like in DeepSeek we saw it was generally in Roman numeral business, uh, but in Gemini it was always academic essays which were preferred, and ChatGPT had layered systems, whereas Claude had engineering categories. So structural diversity is very different in all these four LLMs. Philosophically, uh, one of the tools, which is DeepSeek, was focused on human flourishing, whereas Gemini was focused on risk. ChatGPT was focused on the system, the engineered system, which is hardware approach, and Claude was focused on compatibility, completeness, that everything should be compatible with each other. Training bias, DeepSeek like needed had heavy training, so it can take up what's given. Like Incozy guide was given to it. It trained itself on Incozy and like made a heavy training and gave the answer. Whereas Gemini stuck to whatever academic theory it was trained upon. Uh, Claude balanced between what the Incozy guide gave and what it already learned through the training. And whereas ChatGPT gave deep understanding of both engineering and technical documents. Uh, Summing it up, what strengths do I see and what weaknesses do I see for each LLM? For DeepSeek, the strength I see is regulatory integration. We saw many regulatory compliances were used and they were integrated very good. So this is one of the best features which I saw in DeepSeek. Gemini was like mostly ideation. It was based on cognition focus and was a good conceptual understanding tool. Claude mostly was based on emotional intelligence, and it uh, always managed to balance itself. Whereas ChatGPT was, as I said, more of a deeper systems understanding, which gave it a more hardware approach to its answers, and which is a good strength of ChatGPT. Um, Even after doing all of this, there is one single drawback I have found for them all, is that no single model is complete. No model is alone good for giving you your answers or inputs yet. I hope so it develops itself in future and we get the best ones later. But for now, uh, yeah, no model is just perfect for all types of approaches. On the next slide, you can see two links which will take you to the requirements pages, and you can check the requirements also. Thank you for listening to us. I hope this presentation gives you some more insights into how LLM should be integrated with your systems requirement analysis and system requirements making. Thank you. Thank you for giving us the opportunity to do this.